Hello, my name is Saygun and I'm a second year student at the Department of Molecular Biology and Genetics at Bilkent University. In this video, I will show my PHYS101 project whose name is the effect of different masses on the period during spring oscillation. There are three different masses that will be used. They all are measured with a scale and their weights are 24 grams, 54 grams, and 190 grams. This is the setup of my experiment. There is a setup to hang the spring and a spring with a coefficient of 5 newtons. Firstly, I am hanging the object with lightest weight and I am stretching the spring for 3 centimeters from the equilibrium point. The oscillation time is calculated with a chronometer and the oscillation number is counted by me during the experiment. All of the time differences during all of these experiments are calculated before writing them into the tables. Then, the medium weight is hung to the spring and the spring is stretched for 3 centimeters from the equilibrium point. Then, the object is released and the oscillation number and time are calculated the same as the first one. Lastly, for the vertical spring oscillation, the highest weight is hung and the spring is stretched for the 3 centimeters from the equilibrium point. Then, the object is released and the oscillation number and time are calculated the same as the others. All of these experiments are conducted 3 times in order to minimize possible errors. To find the experimental data of periods for all of these trials, oscillation time is divided by oscillation number and noted in the table. For the second part of the experiment, a copper surface is put with an angle of 70 degrees and the same spring is used to oscillate the same objects that are in the first experiment. The same as the first experiment, all 3 objects are hung to the spring and stretched for 3 centimeters. Later, their oscillation numbers are counted by me and oscillation times are calculated by chronometer. As for the first experiment, all the experiments are done 3 times in order to prevent errors and all data are noted in the table. Their experimental periods are calculated and noted in the table too. The average periods of all the masses in each experiment are found with this equation and noted in a table. The equation to calculate the period theoretically is this equation where m is mass in kilograms and k is spring constant in Newton per meter. As it can be seen, theoretically there are no other variables that affect the period other than mass and spring constant. To calculate, firstly we convert centimeters to meters to use in this equation. We take pi as 3.14 and do the calculations for 3 objects. The error percentage is calculated with this equation. It is conducted in both experiments for each mass. The errors of the inclined plane are higher than the vertical ones. The cause of that can be the friction of the copper surface. The angle might be not still during all the experiments, and there might be an error with the oscillation number and time calculations. Since the error rates of the first experiment are slightly less than the other, we consider the first experiment's error rates to comment on them. The errors during the first experiments may be because of the air friction. There might be an error with stretching of 3 centimeters, and there might be an error in the oscillation number and time calculations. To conclude, theoretically, since only mass and spring constant affect the periods and our spring is the same during the experiment, periods should get higher when the masses get higher. Despite the errors, our experimental data proves this hypothesis. To prevent errors, a surface with less friction can be found, the angle could be checked every time, and the calculations of the oscillation numbers and time can be done more carefully.